first thing here says, use your calculator to plot the position and velocity of the particle for this time period. So what you're going to do is make sure that in y equal, you have the acceleration turned off. So the acceleration is the item in red here. Excuse me. So I use my cursor to highlight the equal sign, and I press enter. That would turn it back on, but I want the acceleration off, so I'll press enter again. Now the acceleration is off. So you do that. Then you hit window. According to the instructions, I want to start at time 0. I want to stop at time 0.3. Then I do zoom fit. And I hit the wrong thing, so try again. Zoom, get the zoom to work. 0. There we go. Wave at me if you need me to come look at your calculator. Okay. Little side reminder before I forget. I sent out an announce. So homework has been a little confusing in this class. My apologies. Just trying to get used to Canvas. I've not used it for class before. So I've established the habit of I give you a homework packet. You take it home, you do your very best to get through the entire packet. The very next class period, I walk around the room, I ask how you did. You tell me, yeah, I finished the packet, I pay you extra credit. What I'm also trying to do is make sure that if I ask you and you say, well, I got through most of it, I just have a couple of things that aren't really making sense to me, that I give you some extra time to come talk to me about that. So what I've got set up in Canvas now is this, and I sent an announcement mentioning this. So let's just make sure everybody's with me. So in Canvas, you see this. You see when you open up Canvas for my class, you get day 1, day 2, day 3, day 4, day 5. So I hand out a packet. The next day I ask if you finished it, I pay you extra credit. But in addition to that, for each packet, there will be this little item here that says certified completion. And basically how this will work is approximately 1 week after I hand you out the packet, that has to be done as well. So I pay extra credit the very next class period. The certification is due like about a week later. Don't procrastinate though. Don't look at this and say, oh, I don't have to do my homework for a week. No, you need to do it day by day. That's why I walk the room and ask you. This is just kind of a final, please tell me, that you got all your questions answered, you have nothing left to work on the packet, then I can give you the 10 points in Skyward, okay? That's what that's for. Questions? Please. So, because I didn't do a very good job getting this started, the due date for certifying the completion of the first 4 packets. So the first 4 packets are the buff, pink, yellow, and blue. That has to be done by midnight on Thursday. Otherwise, you'll not get the 10 points in Skyward. You'll have to come tell me, and then you only get half credit. Going forward, like the new homework today, so the homework tonight is the gold, and I'm going to give you a green packet as well. It's much shorter, but so these 2 packets are the homework tonight. So on Thursday, I'll walk the room, ask if you finished these. You tell me yes, or you say you're close, I pay you 2 points, 2 tickets. Not 2 points, but 2 tickets. But then there'll also be in Skyward a certification that these are done. That would be due like a week from Thursday. And that's how we'll do it going forward. Question? Okay, cool. So that's how that works. Back to the packet we're working on. Richard, if you have this on your screen, you got this far. 2 points. Anybody need me to come look? Okay. That's all it is. For now, we just want to look at the first thing. Just going to turn off the thing.
Can you recognize the song?
I'm seeing
Yeah, I don't. It's supposed to be
yours is still running the system, so you get these little carrots. Or is that he gets the better print. It just makes it a lot easier for you. So, like I said, you can, if you, okay, just leave your tractor with me, I'll fix it for you, and just pick it up. So you should, yeah, you do. Anybody else? Okay, one thing about this worksheet, look at me. It will feel kind of repetitive. Like it feel like I keep asking the same thing over and over. That's by intent. What I'm trying to get you to see is how one graph corresponds to the other. And so there's a lot of things I can ask where you can get the information from, say, the position graph, which is blue, but you can get the same information from the velocity graph, which is orange. So there's a lot of that in this packet, so get used to that. Okay, velocity is the instantaneous rate of change of position. What that means is, knowing the velocity, that will tell you at any instant how fast the position is changing. You do not need to memorize the phrase. I've never seen an AP question that is like that. The AP questions are testing to see if you understand the phrase. So, what is the velocity of the particle at time equals 0 seconds? We can do that 2 ways. I think we showed this last time. From the graph, you can hit trace. Right now, the cursor is on the position graph. I don't want that. So I down arrow. I don't want time 0.15. I want time 0. So I just type 0. Press enter. So the velocity at time 0 is -1. Question. Wave, you need me to do it again? Like this. Cool. The other way to get velocity, which we won't use today as much necessarily, but you'll need it in the future, go to the main screen, type alpha, type trace. We're trying to get the velocity, which is y2. Now it's just function notation. So I go parenthesis, time 0, close parenthesis, press enter. That's the velocity at time 0. Question. Wave like this, go ahead and do it in camera, please.
So when I did that, thing, it just said that it was an error. Can you like?
Let me look real fast. Hold on. So here to see it's just tracing. So there's velocity graph and trace over velocity. The other way to go to the main screen is to go second web. And now do alpha. And then y2, since that's our velocity graph.
Why is it y2?
I know. So here's your formula. So y1 is position.
Oh, now I know that.
Right.
Yeah.
So you go second place. Anyone else? Just wave at me. Okay, so velocity of the particle at time equals 0 is -1. Please make sure you write meters per second. There are many questions on the written section of the AP test where their units are required. So it's best to have the habit of always answering your, putting your final answer with units. So x of 0, that's finding the position at time 0. So let's go back to the graph. Here's graph. Oh, you only have to use zoom fit once. If you don't change anything, you don't have to keep doing zoom fit. You can just touch graph. Go to trace. We're now on position. We're at time 0. Position is 0. I can write it down. So the position at time 0 is 0 meters. What does this symbol represent? So remember, the particle is moving along a line. So I'm representing the particle. The center of the line is what we call the origin, or location 0. So in this particular problem, the position at time 0 is right here. So at time 0, I'm right here. And that's what the symbol represents. You can write that in and check the answer in the back. So, question. Cool. Time equals 0 seconds. Is the particle moving left to right, and how do you know? Okay. Oh yeah, please, Thomas.
Well, I was just gonna.
Yeah, please.
I think it's moving left because the position graph is going towards the negative on the y-axis, so I feel like it'd be on the left, go towards the left.
Oh, that is perfect. So one way, 3 points for Thomas. One way to know which way the particle is moving is to pay attention to the position graph. The two numbers tell us time and position, or time and location. So at time equals 0, particle's right here at the origin. But as I trace forward, time will go up. So if I go to, like, say, time equal 0.1. Well, now the particle is negative at a location of negative 0.067. So the particle was here at time 0. Now it's this way a little bit, because it's at a new location that is more negative than previous. You keep going forward in time. Now that helps if you type the right buttons. Go trace. 0.2. Now the particle is at negative 0.9. Please.
Would checking if the velocity was positive or negative at that point also tell us if it's heading left or right?
3 points for Luke. You have to know both ways. It's perfect. Perfect. So one way, look at the position graph. Notice that my values of position are becoming, as Thomas said, there's another point for him. My position graph shows my position becoming more and more negative. That means I'm moving to the left. As Luke said, another one for Luke, during that same time period, the values of velocity are all negative. Whenever the velocity is negative, particle is moving left. Whenever the velocity is negative, particle is moving left. Question? Please.
So when you're talking about left or right, is that like having to do with like the x instep kind of stuff or whatever? Like because like negative x goes to the left, negative x goes to the right. I meant positive x goes to the right.
Depends on what graph we're looking at. So if you look at the main page of the handout, where we see the large graphs, I think this is what you're saying, 2 points for Cameron. If I look at the position graph, right here, the y-coordinate on position is 0. That means I'm located right here in the center. As I follow the blue graph and go from dot to dot, okay, the particle is, the graph is showing time playing out. So this is saying, like right here, 2 seconds into my journey, I'm now located -25. So I'm over here. 3 seconds into my journey, I'm located at, negative, say, 75. So I'm further over this way. Let's have the whole room answer this. 2 more points for Cameron for asking a good question. Raise your hand if you can tell me about what time the particle stops going that direction and starts going this direction. Like, follow the logic I've just been giving you. Just show me your hands. Like at time 3, the particle was at -25. Sorry, time 2. At time 3, the particle is at -75. At time 4, particle's at looks about 130. So it's way over there. Show me your hands. What time does the particle stop going that direction and start going this direction? You just follow the blue graph and you can see it. Sophia?
Would it be at time 5 because it's what's going
Somewhere in there, I can't tell exactly. Well, I can actually, it's actually right just a little bit before that, but very close. So right there, my position is about that'd be about 155. So I'm way over there. But then as time continues, my position starts going the other way. So right here at time 6, now I'm back to about -75. So I'm definitely moving back this direction. So raise your hand, 2 more for Sophia. If you knew this was the time when the particle stopped going that way and started going this way. 2 points. Is that your question, Cameron?
Yep.
Okay. We want to talk more about it. Okay. So one way we can tell that the particle is moving left is just to pay attention to the position graph. You can memorize this. If the position is decreasing, particle is moving left. Position's going down, the particle is moving left. The other way is, I think somebody mentioned it, it's the sign of the velocity. Negative velocity means particles moving left. Positive velocity means particles moving right. So you can determine which way the particle is moving by looking at either the position or the velocity graph. And that's what item 4 is saying. It says the position is decreasing, keyword is decreasing, at time equals 0 seconds, or the velocity is negative. You are allowed on the AP test to abbreviate the word decreasing and negative, so I'll do that all year. At time equals 0 seconds. So the particle is moving left at that time. Questions from anyone? Cool. Next thing. Okay, so same window. We're still looking at this one. We've already found the velocity at time 0. That's -1, so you can just write that in. It says the velocity at time 0.1. So go to your calculator, trace, go to velocity, go to time 0.1, -0.406. Questions? Wave if you need to look at anything.
I got .0669,
Look.
and I was still more. Oh, it's right now.
I got it. I'll wait for anybody else. Cool. Okay. So far we've talked about position, velocity, and acceleration. Okay, speed is different. Speed is not any of those. You want to write this in your notes. Speed is the absolute value of the velocity. Or you'll hear me say speed is the magnitude of the velocity. Speed is just the number, no positive or negative, just the value. So it says between time equals 0 and 0.1 seconds, is the particle speeding up or slowing down? How do you know? The way to determine whether the particle is speeding up or slowing down, pay attention to the values of velocity. So starting at time 0, velocity is -1. That means the speed is just 1. The negative tells you the directions. The particle is going that way to the left. It's moving 1 meter every second. But it doesn't take, the velocity is changing at every instant. So if I go to time 0.1, well, the velocity is still negative. So the velocity is still negative. Particle is still moving left. But now the speed is only 0.4. So the speed was 1 meter per second. Now the speed is only 0.4 meters per second. So the particle is still going left, but it is going slower than it was. It is slowing down. Questions? So speed's easy to find if you have the velocity. It's just the value without the sign. So, what do you have? Cool. Keep going. So, how do I know the velocity is becoming less and less negative? So particle is slowing. Please, yes.
There's going to be a point in the graph where the changes to speeding up.
So if we look at the big graph, 2 points for Janessa asking a good question. So right here, we're zoomed in right here. It's a little hard to see. This is the area where the velocity is becoming less and less negative. So the particle is slowing. Right about here, the velocity starts to become increasingly negative. That will mean the particle is speeding up. If I look at the big graph, that will continue. So all through here, the velocity is negative. Now the velocity is more negative. So like at time 1, the velocity appears to be about -10, which means the speed would be 10. 1 second, Thomas. Time 2, that's about -35. So the particle is still going left, but now the velocity has increased, not the velocity, the speed has increased from 10 meters per second to like 35 meters per second. The particle is going faster. Right here at time about 3.3, my velocity is now -60, so I'm going left. My speed is just 60. The speed doesn't give you the direction. Thomas first, then Charlie.
So is it kind of as like the velocity graph gets steeper, does the velocity, like is it starting to move faster than if it was like more of a flat line? So I don't even.
Good question.
Well, like, is it wrong to think of it almost like a roller coaster? Or is that completely different?
Different.
Okay.
You're actually referencing what's going to be happening with the acceleration.
Oh, okay.
So the velocity alone, I don't really care whether my velocity is dipping, well I do, but as far as determining whether the particle is speeding up or slowing down, if my velocity graph is going like this, just very gradually, my velocities are becoming more and more negative, hence my speed is becoming greater and greater.
Oh, okay, so the closer it is to 0, does that mean it's kind of, oh, yeah.
Somebody said that last period. If you follow the velocity graph, as the points move away from 0, the particle is speeding up. Right here, those points are becoming less negative, so the particle is slowing. Because the speed is just the magnitude. It doesn't include the positive or negative. Is that your question?
Yes.
3 points, Charlie.
So, like, instead of, like, because I thought, for a second, I thought when it goes to the left of the y-axis, then it's going, like, when it goes to the negative, then it's going left. But instead of this is, like, the x-axis, if it goes to negative, then the particle's going left. But if it goes on top of the x-axis, it goes positive, then it's going to the right.
Let me say it back to you and see if this helps. So, when I look at a given dot, the dot's telling me two things. It's telling me time and velocity, if I'm looking at the velocity graph. So, I don't really care too much about where the dot is located this direction, because that's just different times. I mean, I want to see how it's playing out. What I'm focused on is how far, is the dot negative or is it positive? Are the dots going up or are they going down? So all of these, so this is the velocity of -10. That means two things. Particle's going that way 10 meters per second. 1 second later, the velocity is -35. The negative means the particle's still going that way, and now it's going 35 meters per second. I think I'm saying what you already knew. Does that confirm what you're asking?
Kind of, yeah.
If I go over here, okay, everyone in the room get a point for this. Don't overthink it. Just look at that dot and tell me that's time about 4.8. Raise your hand and tell me what's the velocity right there. Hands. Don't overthink it. Just look at it. At time equal 4.8, what's the velocity, Colin?
0.
How many agree? 2 points to me for call. Raise your hand and tell me if the velocity is 0, what does that mean? Come on, just don't overthink it. You know it. The velocity is 0, what does it mean? Hands, come on. What does it mean? Stop. So when the velocity, how many knew it? 0.2 for record. So when the velocity is 0, the particle stops. Now back to Charlie's comment. Watch the dots now, Charlie. If I go to say time equal 5, now my velocity is like 15. Positive velocity means I'm moving that direction. If I go to time 5.5, my velocity is now 70. So I'm still going to the right, but I'm going much faster to the right. Is that your question?
Yeah, got it.
There we go. Please, Christine.
On number 6, was the speed just 0.4?
Let's get there. So we've got 4 done. We've already done these two, so wrote those in. Oh, I got mixed up where we're at. I'm sorry. Number 6. What is the speed between time 0? Well, what is speed? Speed's just this. We weren't actually finding a specific speed. We were just defining the meaning of speed. Is that what you meant?
Yeah.
Okay. 2 more. Anybody else? Okay. Again, a lot of these questions will seem redundant, because the whole idea is just to make sure you see how things correspond to each other. Between time 0 and time 0.1, the seconds, the velocity becomes less and less negative. So moment by moment, the particle is moving less and less to the left. That's why during that time period, the particle is slowing. Okay, next thing. We're supposed to plot a window of 0 to 1, so just change your calculator quick. Zoom fit. we've already found the position at time 0, that's 0. It says find the position at time 1, so you've done this before. Hit your calculator, go trace. Set the time to be 1 second. Position comes out to be -3. Wave at me if you need me to do that again. So gotta make sure my window's correct. Time 0 to time 1. So I've got that. I zoom fit. Trace. I want to be on the position graph, so I'm on the correct graph here, the blue one. But I want my time to be 1, so I just type 1. And now my position at time 1 is -3. Anybody else just worry about me? Okay, back to here. Next one says, take the position at time 1, that's -3. Subtract from that the position at time 0, that's -3. This is known as displacement, by the way. When you take one position, subtract another, you're finding the displacement. Or change in position. Again, a lot of redundancy on this worksheet. Between time 0 and time 1 seconds, by what amount does the position of the particle change? That position changes by -3 meters. It's crucial you understand the difference between a position versus a change in position. Like, for example, this says -3 meters. That's referring to a specific location. In my little example, that's saying, okay, here's location 0. So here would be location -3 meters. So that's a specific position. This -3 is different. This is a difference in positions. So it's like from here to here is a difference of -3. So displacement is different than position. Here I am at a location of -3. From here to here, that's my displacement during that time period. Question? Awesome. New word to memorize. Velocity itself is instantaneous velocity. There's also what's known as average velocity. And you'll be tested on understanding that in kind of 3 different ways. They're all the same thing, just expressed differently. One way is to say the average velocity is simply the change in the position divided by the change in time. But we calculate change in position by simply finding the difference in 2 positions divided by the difference in those same 2 times. Another way to write it would be like this. And then a 4th thing to remember is that's also the secant slope of the position. So these are in your notes, so you'll get them memorized. So if I look at the graph, my position right here is 0. So time is 0, position is 0. Over here, time is 1, position is -3. If I draw a line connecting those 2 points, that's known as a secant line. And the slope of that line, the secant slope, you've been calculating slope for a long time. That's just the change in the y-coordinate divided by the change in the x-coordinate. So that's why that secant slope is -3. That's your average velocity, meters per second. Please.
So will the displacement and the secant slope be the same most of the time?
3 points. No. In this case, it turned out to be the same simply because the time period was 1 second. When the time period is different, they'll always be different. Well, typically be different. So most often they're not the same. I should have picked a better example. That's my bad. Good question. Maybe else? Okay. It says, what is the average velocity for time 0 to 1? We've already done that. The average velocity is -3 meters per second. Number 11, again, it's kind of repetitive. Therefore, on average, the particle's position is changing by -3 meters every time 1 second of time elapses. That's what is meant by the word average velocity. Questions? Cool, keep going. Okay, so now they ask us to plot what's happening from 0 to 7, so just do your window again. Wave at me if you're having trouble on your calculator. It's waving. Okay, we already know the velocity is, so the difference is this. Okay, the velocity tells you how fast is my position changing at any instant. Like right at that instant, how fast is my position changing? That's instantaneous velocity. Average velocity says over a time period, from this time to this time, on average, how fast is my position changing? So the symbol for average velocity was this one. And then here are different ways to calculate average velocity. Instantaneous velocity is this symbol, because it has to specify a time. dx over dt, new symbol to memorize. When we were finding the average velocity, we were finding the slope of a line between 2 points that are separated by 1 second of time. So 2 distinct points. When we calculate instantaneous velocity, what we actually calculate is the same thing, except you can't really see it. Because you have to imagine that you have a point right here, and instead of the other point being some distance apart, the 2 points are infinitesimally close to each other. And you're still calculating the slope between those lines. So notice, average velocity looked like this. You had the change in the position divided by the change in the time, which is the slope of the position graph over that time period. The D means infinitesimal difference. So it's still a difference in 2 positions divided by a difference in 2 times, but those 2 points are infinitesimally close. We'll talk more about that later, but that's enough for today. So this symbol means instantaneous change in position, or instantaneous rate of change of position, or instantaneous velocity. Another way to write that is called x prime of t. It's an apostrophe. We use the word prime is what it's called. So these are different symbols to represent instantaneous velocity. They turn out to be the tangent slope of the position graph. So here, when we were finding average velocity, we were finding the secant slope between 2 points. Here, when we're finding instantaneous velocity, is the tangent slope. 12 says at time equals 6 seconds, the tangent slope of the position graph is what? So, if I go right here on the position graph, if I want to find that slope, I can ask my calculator to do it. So I can go to the calculator, go second quit, clear. I want to find, look at the worksheet again, this is in front of you. I want to find at time equals 6 the tangent slope of the position. So I want the change in position over change in time at time equals 6. So we'll learn how to do it without the calculator later, but for today the calculator will do. You type math 8. I want, the bottom's got to be time, but in the calculator, this is kind of confusing. In the calculator, x represents time. And I want to find the change in position. In my calculator, the position is y1. So I go alpha trace, choose y1. So in the calculator, I'm doing the change in position over the change in time, which is the same thing as I wanted right here. I want to find the velocity at time 6, which will be the change in my position divided by the change in time. I want to find that at a time equal to 6. That's what I'm working on. Just the symbols change as you go from paper to calculator back to paper. Wait, you need to go through that again. Okay. So back here, now I want to go to time equals 6. Press enter, 155. So the slope of the position graph, the tangent slope right at this spot, I'll do my best to draw this. So the slope of that line, that tangent slope is equal to 155. Question? Please, Nick.
On my calculator, when you do math 8, it goes this weird line.
Yeah, that's because we have to upgrade it. So no worries. So just hold tight on that. We'll get that fixed. Anybody else? 2 for Nick. Oh, please.
So it's plotting the points that are infinitesimally close to each other.
Say it again, Jordan.
I'm confused on the slope.
You're okay. What the calculator really does is it zooms in as close as it can. It takes 2 points that are, they're not infinitesimally close on the calculator, but they're numerically very close. And the calculator calculates the slope between them. And it found a slope of 155. That's what this symbol is indicating here. Go find the slope between 2 infinitesimally close points. That's your question. 2 more. Anybody else? Okay, but look at the symbols here. So we found the slope of the position graph, the tangent slope using the calculator, but the tangent slope is exactly the same thing as the velocity at time 6. There's no difference. So if I go up here to the velocity graph at exactly the same time, that y-coordinate must be 155. So if you go to your calculator, go to graph, hit trace, go to time equal, go to the velocity graph, go to time equals 6. Sure enough, the velocity at that time is also 155. You have to know that they're the same. Okay, they're the same thing. Please.
So why can't you just go to the back one and just put in the time?
3 points for Nick. You absolutely can. What will happen on the AP test is they won't give you both. And so depending on the question, you'll have to know that either way works. Does that make sense? Yeah. No, you can find it from either one. It's just going to depend on what kind of question they ask you. So, anybody else? Okay. So the slope of my position graph is 155. At time equals 6, this is exactly what Nick just said. At time equals 6, the velocity of the particle is 155. Again, the worksheet feels redundant because, as I just said to Nick, there's 2 more for him. trying to help you see that they are the same thing, that you're finding the same thing in different ways, because you'll be required to do that. This says x prime of 4. That means find the slope of the position at time 4. You can do it either way. I can go back to my main screen, say I want the positions, that's math 8, slope of position, that's y1, alpha. Want to find that, come on, want to find that at time 4 now, negative 49. Velocity at time 4, I can do that from the main screen as well. I can do alpha, trace, choose velocity, which is y2, find that at time 4, like that. Wait, can you need me to do that again? Okay, hopefully
Don't you have to put the more in parentheses?
yes, because you have to specify the time. So, two for Jonah. There's lots of different velocities. We want the velocity at specifically time 4. Like here, we're finding the slope of the position graph at a specific time. Same thing here. So, anyone else? Cool. Back to here. So this is also negative 49. You should also be comfortable with looking at the graph and noticing, let's use my paper picture, it's a little bit easier to see. Okay, we're at time 4 now. So at time 4, sure enough, the tangent slope of the position right there, that I used to draw so well with my old board, and I've got to learn to do this one now. That's not too bad. The tangent slope right there is, what do we find, negative 49?
Yeah.
And another point for Nick, sure enough, the velocity at that exact same time, if you look over here, that velocity is also negative 49. Question? Sweet. Keep going. What's my time? Number 15, at what time does the particle stop moving left and start moving right? It says, how do you find this time using the position graph? How do you find this time using the velocity graph? I believe we talked about this earlier today. If I'm looking at the graphs, we'll go back to the big picture, it's a little easier. If I'm looking at position, here my position values are becoming increasingly negative. Position values become more and more negative. So as those values become more and more negative, the particle is definitely going to the left. Right about here, the values stop becoming more negative and start becoming less negative. So now the particle is moving to the right. At this moment, the particle is at the origin again. So way over here at time 0, the particle is at location 0, meaning the center. For all of this time, the particle was moving, for all this time, the particle was moving further and further left. Beginning right here, the particle stops moving to the left and starts moving to the right, but it's still located way over here. It's coming back this way. Right at this time, 6.4 seconds approximately, I'm back here at location 0, which is known as the origin. Questions? You can see the same thing, well, not totally. So that gives you a really good picture of like which way the particle went, how far it went, came back. If you look at velocity, you'll notice a correspondence. All of these velocity values are negative. which means the particle is moving left during this entire time. It's not until here, notice how these line up perfectly. That's the exact moment when the particle stopped going left and started coming back to the right. That's what question 15 is talking about. Questions? Okay, keep going. It says add the acceleration of the particle to your graph. So, go back to here, get y equal, turn on the acceleration. I'll need to zoom fit again to get everything to fit properly. Wave at me if you need me to come look at your calculator. Cool. So now we have all the graphs shown. Back to the worksheet. Acceleration is the instantaneous rate of change of velocity. In exactly the same way that velocity describes how fast the position is changing, acceleration describes how fast the velocity is changing. So the symbols look very similar. Here's acceleration. Acceleration is dv divided by dt. The instantaneous difference in velocity divided by difference in time. It's also v prime. It's also the tangent slope of the velocity. So very similar to, so in the actually not even similar. Position is related to velocity in exactly the same way that velocity is related to acceleration. So if you get very comfortable with understanding one relationship, the other one is exactly the same. There is no difference. What is the acceleration of the particle at time equals 0? So go to my calculator, hit trace, get to the red graph. So now I'm on the red graph. Choose time equals 0. At time equals 0, my acceleration is 8. Write that down. Time equals 0, my acceleration is 8. The units are meters per second every second. So the acceleration at time 0 is 8 meters per second every second. This is more related to what Thomas asked about earlier, another point for him. This says, at that exact moment in time, my velocity will be going up by 8 meters per second every second. It tells me how fast the velocity is changing at that moment. Please.
Why did we use the
This one here?
Yeah.
2 points for Jonah. We absolutely can. So we can say, hey, let's go find, instead of like just reading the acceleration, let's go find the slope of the velocity, because they're the same. So I go back to here, go to the main screen, clear, go Math 8, choose velocity now, that's y2, find it at time 0, and it will be exactly the same. Perfect. Questions? Okay, listen really close. All eyes on me so you don't miss this one. So everybody looking here. Okay, this little interaction thing where you check your calculator, read some stuff, fill out the blanks, it continues on the gold, but it also continues on the green packet that I'm about to hand to you. So the homework's really pretty simple tonight. You just keep reading the question, look at your calculator, fill in the blanks, check your answer in the back. There's not really any computations per se, it's just getting used to the idea of how the three functions relate to each other. So homework is finish the gold and the green. Question? it goes pretty easy. It's really not a bad assignment. So. Good work, you guys. Got about 90 seconds. So. Stop recording
I think that's a